So we are live. Hello everyone. I welcome you all to day 3 of iTalk series on data analytics. So without any further delay, let's start with the session. So you may proceed now.
Okay, thank you very much, Palak. Now we'll be starting day 3, and as we were discussing yesterday, we are having completed most of the Python sequences except the dictionaries, and we will have a look at dictionaries. Dictionaries are also important from data science and data analytics point of view. That is because many of the formats which are very widely used. I discussed a file format yesterday called as comma separated values (CSV) files, and very similar to that, the file format which is very common, in which the data is exchanged nowadays in the contemporary database as well as enterprise corporate systems, is what is called as a JSON file. Now, JSON file is essentially having its origins with Java, but it is having a structure which is very similar to that of a dictionary. So concept of a key value pair which is there in JSON file is also there in dictionary, and therefore importing JSON files into dictionaries and consequently also into the pandas data frames from dictionaries is a pretty straightforward process. It makes it pretty easy and direct for handling the JSON files. So this is another way of doing a data exchange universally. So you will find that the data is exchanged in these two formats, that is CSV files and JSON records or JSON files. That is what is the most widely used. So let's start today's session. In the today's agenda, we will be having completion of dictionaries, and then we will move on to functions. Not really spend too much time on functions, but we'll give an idea of how the functions and the modules and the packages work in Python, and how it is really very easy to create a module and a library addition in Python, how to use those libraries in Python, and that also automatically paves way for us to use different tools and libraries which are available worldwide on thousands of libraries on hundreds of different subjects which are available on Python in open source. Okay, so again, usual to this, saving bandwidth, I will just turn my video off and I will start sharing my presentation for the screen. So, as I said, we will complete the dictionaries, which was a small part remaining from the yesterday's schedule, and then we will move on to see functions, modules, packages. And after that, of course, we know that we are going to study a number of tools. So essentially, we are going to have an overview of four different tools, and those four different tools are the ones which we are going to study are those tools which are used very widely in data analytics, namely NumPy, which is for essentially number processing or number crunching. Then we'll be using pandas, that is for essentially handling the two-dimensional databases in memory and perform various processing operations. So pandas are what you can say a base or key for performing any dataset operations in Python. All the other tools work on top of basic data unit, which will be a data frame in pandas. Okay, so what a two-dimensional table is stored on a disk. The same two-dimensional table from the database is what in the memory, in the operating or workspace of your Python is data frame from pandas. Okay, so we'll be seeing NumPy, we will be seeing pandas, we will be seeing a data visualization library which allows us to do graphs and plots and charts, which is matplotlib. And then we will see some of the statistical methods and tests which are incorporated pretty nicely so that we don't have to go too much deep into statistics. Of course, we must be knowing some basic things about it, but generally, we don't have to go very deep into the statistics or learn statistical formulae. And without doing that, we can very easily just go on working with those statistical analytical functions with scikit-learn. So these are the four libraries which are very useful for us that we will be studying. When I say studying, I will, as I'm saying, it will take the overview of that. Okay, for example, like say pandas is so huge or big that only pandas can be a skill development unit or a module of a course, which can run for say if the course is of 10 or 15 days for 2 to 3 days, only pandas. So that is there, and then of course we will end up with a real world example. So we'll straight away start now. Today, I wish to complete, as I said, dictionaries followed by functions, modules, and packages, followed by a generic, what you can say, a basic overview of how the data science and analytics works, what are the steps involved in data science, which essentially go on to process the data, and then we will take at least try to complete one tool, that is NumPy. Overview of NumPy we will try to finish off today. If possible, we will see a little bit of pandas toward the end, or other way around. We may also try to squeeze in alternately, if time permits, some a short view on files, because finally the data is coming and going in files, so we should be knowing little bit of at least file handling in pandas. So we will try to have a very quick overview of files, uh, if we are able to squeeze in today itself. Otherwise, tomorrow we will see files and pandas and matplotlib. Okay, so let's start right away. Okay, so let's move on to see the dictionaries in Python. Dictionaries are also sequences, and they are having what is called as a key value pair. Means essentially here the index is a key and value is of course a value. So rather than index which is hidden for other Python sequences we had seen, maybe may it be tuples or strings or lists. Okay, the very first element in the list or tuple is having index 0, the next one having index 1, the next one having index 2, and so on and so forth. So generally we say that the indexes are fixed to be 0 to n minus 1, but here in dictionary the indexes are allowed to be any data type that we may choose to have, and that is called as a key. So it happens to be a key value pair. So if you see a lower on the side, you will see that we have created one dictionary where we are having uh, ABC to be a key, and at that key the value stored is 23.45. 33 is the key, and 433 is the value stored in there. 87 is the key, and hello is the value stored in there. So therefore, we were using indexes with numbers up till now, and for list we were doing say li 0. Here I am doing DI ABC. So instead of index, the keys are behaving as indexes, and therefore I am doing di into square bracket ABC. So it is just like what we can say in list, the zeroth element is having some value. Here the in di, in dictionary, ABCth element is having value 23.45. That is what is shown in here. So dictionaries are having very peculiarity, as I said, they are very reminiscent of what is called as the JSON format and the very widely accepted interchange format for data, which is there. So we can do addition to the dictionaries, we can do modifications to the existing values in the dictionaries. And both of these are quite a simple processes. Okay, so rather than doing it in the presentation, we will go to our usual screen where we were seeing so many things till now and try to do the same here itself. Okay, so we are having the spider screen, which must be visible to you all now. Now let's try to create a dictionary. So I say D1. So D1 is a dictionary, and I will create it with a open curly bracket. I can say I will have a value, as I say AB is the key value where the data store is 22.334. Then CD is the value where data stored is 324. Then 35 is the value of key where data stored is FE, and close curly bracket. Unfortunately, I had put a quick return there, but there is no harm. I can still complete the line. So I have completed it with close bracket. Ideally, everything should have been on a single line. No issues. So if I say D1, you will see that at index AB, or what is called as at key AB, we are having value 22.334. At index or at key CD, we are having value 324. And at index or key 35, we are having value FE. So if I say D1 35, it will return me FE as the value of that location. Okay. If I want to change that from Fe to say Cu, say from iron to copper, maybe if you are into chemistry, I can change it. And now if I happen to look at D1, you will see that the third value has been changed to Cu. So what does that indicate? It indicates that it is pretty straightforward to change any dictionary value by just making an assignment to the key of that particular element. Number one. Number two, that dictionaries are mutable. Okay. Dictionaries are mutable objects just like lists. And being mutable objects, I can change the individual element of the key. When I say I can change the individual element of a particular dictionary, we have to keep in mind that what I am planning to change there is a value. A key once entered cannot be changed. It can be deleted, but it cannot be changed. Okay. So now AB cannot be changed. I can delete the entire element with key AB and value 22.334. But and I can also assign to the key AB a new value very easily, just like what I changed FE to CU above. But I cannot change for value to 22.334, I cannot change the key from AB to anything. Okay. What can be the keys of dictionary and what can be the values of dictionary? Okay. A dictionary key can be any data variable which is not mutable, and value can be any data variable which is either mutable or not mutable, unmutable. Okay. So in fact, values can be anything. That means values can be integer, they can be string, they can be float, they can be complex numbers, they can be tuples, they can be lists, anything. What can be the keys? The keys can be strings, the keys can be integers, the keys can be floats, etc. So, in general, only those objects or variables in Python which are not mutable or which are unmutable. Okay, so keys can be any unmutable data variable, and values can be any variable in Python, either mutable or unmutable. Okay, so that is how about D1. Now, how I can add element to the dictionary. For dictionary, the append method is could have been there because it is a mutable object, so appending to the dictionary is very much legal, legitimate, but it is not needed simply because if I want to add element to the dictionary, I have to take a value which is not there in index. Say I say 444 as the key, and if the value is going to be 34.56, and sorry, key is of course in the bracket, and if the value is going to be 34.56, I can add it to the dictionary. You will see that the dictionary was having three elements, having keys A, B, C, D, and 35. Now we'll have four elements having keys A, B, C, D, 35, and 444. Okay, so adding element to the dictionary is also quite simple, where you can just add the key inside a square bracket for that particular dictionary and assign value to it. Okay, now the key 444 is created. Only key cannot be deleted. I can delete the whole element or I can change the value of 444. If I say, "Nah, I don't like this value," I say that the value should be EDX. Okay, I can do that. And you will see that now key 444 is having value EDX. Okay, so this is the way you can access the dictionary elements. You can access the you can access the dictionary element. You can change the dictionary element. You can add a dictionary element. You can delete a dictionary element. That is, we will see in a while how we can delete a dictionary element. So all these things can be carried out with dictionary element. Okay, if I say given dot pop, pop item, given dot pop item, if I do that, you will see that it will pop out the last item put into the dictionary. Okay, we must have seen the LIFO functions like push and pop in some other previous languages, mainly like say in the assembly languages. So here a pop item pops out the item which is put into the dictionary last. So because I had put last 444 key with value EDX, it has been popped out. Now if I happen to see the dictionary, it will again contain only three elements, because the fourth element having key 444 and the value edx has been popped out. This is effectively from equal to removing the element from the dictionary. This can remove the element from the dictionary which has been last put into the dictionary. So I can also do d1 pop, and I have to put a specific key. So I will say, if I am saying I am removing the item which is having value, which is having key AB, you will see that the value 22.334 will be popped out. That is, effectively it will be removed, and you will see now that the dictionary is having only two elements, because first I did the item popping, the last put in item was popped out or removed from the dictionary, that was for 444 key edx value. And then I also removed the element which was having key AB, which was nothing but AB and having value 22.334. That also got removed. So this is the another way of removing a particular element from the dictionary. Okay, and of course, if I want to wipe out the entire dictionary, I can always say di, whatever is the dictionary name, dot clear. So clear method clears the dictionary. You will see that the dictionary still exists in the name d1. So d1 is not returning that the variable is not having or not existing. The variable in the name d1 exists. It is also of type dictionary, but there are no elements currently in this dictionary. So if I say type d1, you will see that still it is showing dictionary, means the empty dictionary exists at that particular position, and therefore d1 as a variable is still valid, and therefore if I am putting in d1 33 equal to 4.44, that will accept, and now d1 will have one element only which is having a key value 33, and which will have a key 33 and value 4.44. So, in this way, the dictionaries can be manipulated. Okay, what all things that we have seen? Dictionaries are having key value pair, dictionaries are Python sequences, dictionaries are mutable, the key values can be any unmutable Python variable, the data values or the values in a key value pair can be any unmutable or mutable, in short, any Python variable. Uh, we can add an element to dictionary, we can access a single element of the dictionary, we can change or modify a single element of dictionary, we can remove the last put in or any middle element with a particular key. So any specific element of the dictionary can be removed. So all these operations can be performed on dictionary. Okay, so that is what is these slides. Okay, as I said, all the presentations will be available with you, so you can have a look at them. Some examples are given in there itself, but we are also I'm also going to share with you all the programs, and therefore you will be getting those details which are related to dictionary. So the bigger programs I am trying to avoid because of, as I said, time constraint, but the regular course we do take bigger programs, and those programs I will be bundling them into a single zip file and handing it over to your people, so that the context of every topic that I covered is complete. Okay. Now you will see that only keys can be returned, only values can be returned, and a whole of items can be returned by three simple uh, commands, that is dictionary.keys, dictionary.values, and dictionary.items. Okay, so we will have a look at it on the editor very soon. Also we can do dictionary comprehension. As you can see, the top one, x is xx, and for x in range 13, which is very same to list comprehension. And we can also carry out the iterations through dictionary using a for loop, which is again very similar to what we did for the list. So dictionary comprehension works very similar to list. So we are having on keys, membership tests can also be done or carried out on dictionaries. Okay. So all these functions related to dictionaries we will see one after the other now in our program. Okay. So let's see. Let's do. I think I will restore D1 to the original one, so at least it will have 3 4 elements. Okay, so B1 is having 3 elements now. Okay, so if I say len of B1, I can get the value of 3 because B1 as a dictionary is a sequence of 3 elements. Okay, now if I say B1 dot keys, it returns me the list of keys in the dictionary. You will see that it is returning me AB, it is returning me CD and 35, which are the keys. Okay, if I say given dot values, it will return me only the values in it. And if I say item, it will return me key value pairs in a tuple inside a list. So you will see that actually dict underscore items. What all things are there? Actually, there is a square bracket. That means essentially it is a list and it is containing a key value pair tuple. So AB, comma 22.334, that is seen inside a round bracket, which is in Python a tuple. So first tuple indicates first item, second tuple indicates second item, and so on and so forth. And all the items are part of the list, which essentially represents the contents of that dictionary. So three functions we can actually check only the keys, only the values, only the items. Okay. If I say CD in D1, it will return. This is what is called as membership or element check. So CD, is CD a valid key in dictionary 1 D1? Yes. Is AB so? Yes. But is 44 in D1? No. It is not an element in the D1. So no key matches 44. 35 would have matched, but 44 is not matching. So it falls. So we can do a membership testing on the dictionary. As I said, we can carry out dictionary comprehension in this thing. So I can say D2 is equal to x colon, I will say x cube for x in range, suppose 5. Okay, let's do it 5 only. And I'm closing the dictionary. Okay, so I have created a dictionary of first 5 number cubes. But of course, because I have said range 5, it will generate cubes of 0, 1, 2, 3, 4. Okay, so let's see what D2 is. Okay, you will see that the x is a key and x cube is a value. So it says 001128 327 and 464. Okay, these were the cubes which were generated. So this is an example, very easy example of where a dictionary comprehension works in a fashion very similar to list comprehension. Okay, list comprehension we have already seen yesterday, where a Python syntax, a single liner syntax, can go inside square brackets of list. Here, similar way, they can go inside the curly brackets of dictionary. Okay, so this is what is about the dictionary comprehension. Okay, dictionary comprehension. You, because the dictionary indexes are not 0 to n minus 1, we cannot carry out slicing, because for slicing I must have a start stop and if optionally a separation. But for that you must have indexes to be numerically arranged 0 to n minus 1 or minus 1 to minus n if we are going in the reverse order, which is not the case with dictionaries, and therefore a conventional slicing doesn't work with the dictionary. It is not working with the dictionary. Okay, so all these things we have just seen, which are related to the dictionary, what we saw here just now. So membership tests, dictionary comprehension, and then the functions which are there, such as keys, values, and items. Okay, we have already seen the pop item functions and clear functions which are available with the dictionary. You can also use a delete command. So delete can be done with whatever is the number of key. So you have to member key has to be specified, and you can also use a delete. Okay, so you can delete a specific entry by pop or delete function or pop method. You can remove the last entered item by pop item method. You can remove all the items by clear method. Okay, so these are the different ways in which dictionary values can be altered. Okay, so basically dictionaries, as I said, because of their key value pair kind of a situation, are very crucial, and they are very helpful in understanding the JSON data interchange formats, which are used as widely as CSV files in the industry. Okay, so you may see if we are talking about some IT people from companies, they will say that okay, data ऐसा है वैसा है, okay fine, data ठीक है CSV में भेज दो, और या फिर मैं एक जेसन भेजता हूँ, यू कैन टेक इट, ये टाइप के colloquial or this type of conversation you will find in the industry. So both these formats are pretty good and they get supported, and we've already seen them. Okay, so uh, in short, dictionaries are the sequences. Dictionaries are having key value pairs. They are mutable and they show all those properties that we have seen just now. Okay, so that is as far as the dictionaries are concerned. Let's move on to functions. So Python function is a group of related statements that perform a specific task. We know that functions are being used for uh, essentially writing uh, tasks which are repetitive in nature, and obviously the entire code block is written down once, and whenever it is required it will be just what we say that a function is called and the entire code block gets executed. So sometimes some languages classify between a procedure and a function. So some languages say it is same. Okay, Essentially, languages sometimes say that procedure is a function without a return parameter. So such procedures are nothing but functions with a void in C. So same thing is there in Python. You don't have to explicitly specify whether a function is void or not. If you are declaring a return value inside a function, it will return a value. Otherwise, it will not return a value. Okay. So explicit declaration whether the function is void or not, or other way around, whether it is a procedure or a function, is not required in Python. You can straight away write down the function. Okay, so we also know that the procedures make or functions rather make your code more structured and more modular and organized. Okay, so this is what functions in any language, and same way they are the functions in Python. Okay, so how a function works in Python, how it is created. Okay, function is created with the keyword def, def. So we are defining functions by keyword def, and therefore let's try to write a very simple function. Okay, because now we are writing function and we will be writing some indented blocks inside the function. I will take help of some uh, program rather than doing it from the command prompt or doing it at a IPython prompt. So we have to write say def. It will become a keyword. Okay, so I will say test one, and name, as there is no declaration, data type declaration will not be there. And obviously we have to, because a function is going to execute set of statements, it will be there with a colon as an initiator of that indented block. You will see that automatically we have shifted four spaces. And then whatever I want to write in the function, I can write say print and then say print. Hello name. Okay. So this is my function. Okay. This is my function. Okay. Which I have created. So I will store it as a file in our, I will maintain the same folder, desktop, NIT lectures. Okay. And program 6, suppose. I is what is getting stored. Okay. And when I execute it, obviously I will need a name, but this is just a function that I have written. So I need to write a main program, and the main program will be just calling the function. Okay. So if I call the function, okay, I will say, uh, I will need the name to be received. So I will write my name is equal to input, enter name. Okay. And then I will call the function test1 into bracket my name. Okay. I will call it. Okay. So this is my main program. Okay. So function is being written and it has also been called in my main program. So let's run this. Okay, it is asking. So I will write say my name is Shrikant. Okay, and you will see that it is saying hello Shrikant. Okay, so the function has executed. Okay, the function has executed. So this is the way we can write functions in Python, and this lays down the very basis of creating all sorts of functions in Python. We will see, just as I said, we can here also, there are a lot of things which are there, but we can take only some overview of these functions and modules. We will just try to run through it, see couple of very basic features of functions in here. Okay, so there are parameters which can be given. You will see that where, as I said, name is a passing parameter. Now, because I have not returned any value, this function is not going to return anything. Okay, it is not going to return anything. So this particular function is uh, what you can say, a function which is with can be equivalent to be a void function in C. Okay, so because there is a passing parameter, I can give some value to it as a default value. I say man is the default value. Okay, so what is going to happen is, let's see, I will run test 1 without passing any parameter, and in second case I will put the parameter because I have just received the name. So let's see how it works. Okay, so if I run this, you will see that it is asking me name. So, okay, I again enter Shrikant. You will see that the upper test 1, I have not done a passing parameter. So it says hello man, taking a default value for name parameter. And in second case, because I passed the parameter, it is allowing me that parameter to be passed, and then it will be assigned in the print statement and it comes back. Okay, so that is the way you will see that you can specify parameters which are having default values. Now let's say explore this a little bit more. So I will open a new file. I will close our program 6 and I will be saving this as program 7. Okay, so let's save this as program 7. Now what we are going to do is I'm going to write function which is say animals. Okay, animals, and I'm going to write say A comma B comma C. Okay, and of course a colon for the indented block, and I will assign parameters. A is okay, A is a dog, B is also a dog, and C is also a dog. So in general, for all passing parameters, my default value is going to be dog. Okay. Now I will do just like before, print and another print which will say A comma B comma C comma okay. So all these are ABC are animals. Okay. So now I am written down this particular function. Now let's write a main program and try to see how it works. Okay, so what I'm going to write in main program, let's see. I'm going to call the function once animals, animals, and I am passing all the three parameters. I say tiger, lion, elephant. Okay, tiger, lion, elephant are animals. Okay. Now I am going to call this function once more and once more and once more, and every time I am going to specify parameters which is one less. Okay, so here I only pass two parameters. Here I only pass one parameter, and in the last case I don't pass any parameters, and we will see how it works. Okay, let's run this. Okay, so you will see that what has happened is tiger, lion, elephant are animals. Tiger, lion, dog are animals. Tiger, dog, dog are animals. Dog, dog, dog are animals. Okay, so what has happened is that how it works is pretty simple. If you pass only one parameter, the first parameter will be okay. So which parameter actually got replaced? We are not clear. So what I will do is I will say dog 1, dog 2 and dog 3, and we will execute this once more, and you will see that it says tiger, lion, dog 3. Okay, so first two passing parameters were replaced by actual values in the second case. First case is of course straightforward. In third case, it did slightly different because only one parameter was passed, it was taken, and so on and so forth. So it went on taking default values. In the last one, we didn't pass any parameters, so all three values were taken. So now the question comes that okay, is it possible for me to pass only the second parameter or only the third parameter, or it will be always by default if I pass one parameter that will be treated as a first parameter? So no, we can do that. And how can we do that is by saying animals b is equal to a cheetah. Now how it works, see. Fine. You will see the last line is indicating that dog 1, A was not passed. We passed only one parameter, but that was explicitly B. B parameter which was passed. So it replaced B with cheetah, dog 1 and dog 3. So first and third parameters were not passed, and therefore it defaulted to the values dog 1 and dog 3. So in short, we can specify the parameters, we can specify the number of parameters which are less than the total number of parameters asked in the function. However, if it happens to be so, we must have declared or we must have told the def or the function about its default values if the parameter doesn't get passed, as if the number of parameters passed are less than the actual number of parameters to be passed. In such case, the parameters will be treated as passed. Okay, and of course it is less than the total number of parameters available. It will just go on assigning from first to wherever up to whatever point it is able to pass. The remaining values will automatically default. But if I want to specify only some parameter which is a middle parameter, somewhere which is not the beginning parameters, only one parameters explicitly, I can do so by having the parameter reference equal to the new parameter value that or the parameter value that I want to pass. Like what we did, b equal to cheetah. So I explicitly said that I want to pass parameter b in this particular case. Okay. So this is another what you can say very peculiarity or speciality of Python functions as regards the passing parameters. Okay, just have a look at. Fine. So I have just talked about the same thing, and it is same word, similar example. So we are having default parameter passing in functions. Now let us have a look at a return value and how it works in this particular way. Okay, so we will go again and check about the return value. Okay, so now we say here only let this part be running without. Keep in mind, between two def declarations, there has to be one line. Similarly, between a particular function declaration and the main program, there has to be one line. Okay, so this line, which is at the 11th line, which I have just highlighted, is very important. Okay, it indicates two things. One, that the indented block has finished. That means the body of the function or body of the statements of the function is over, and therefore the next line will not be treated with the same indent. Okay, that is very important. So if you are writing number of functions, like say two functions, and my main program is going to be something, then I will be having at least one line spaced between the defs of two functions. Similarly, between the last def or function and the main program. Okay, fine. So I'm writing one more function here itself. In this itself, I'm writing one more function. So, okay, and prototyping and pre-declarations of the functions are not required in Python. We will see that very soon. So, I'm writing another function, breathe, and I will take the name, same thing, and I will write same print what was there. So, say good day, name, and one line which is important. So I am using this, and I am returning len of name. Means how many characters the string contained in the name. I am returning that. Okay. So I am returning a value in here. And also I am writing one more function which is very similar to that, where I will not be returning any value. Okay. So I won't return any value here. I will just remove this. Of course, two defs cannot have same name, so I will change the name to greet1. Okay, so I am changing it to greet1. Okay, now I will say greet. I am calling that function greet Shrikant, and greet one, say Raju. I can also have a function called within a print statement. So I can say print greet Rajesh and print greet1, say Rocky, some names. Fine. So now let's execute. Okay. So first lines you just forget because they are related to the previous one, animals. Okay. And after that, you will see that it has come. Good day, Shrikant. Good day, Raju. Good day, Rajesh. 6. And Good day, Rocky. None. Okay. Now, what are these lines? Okay. If I see greet Shrikant, it has come good day, Shrikant. The function got executed. Greet one function got executed and it said good day, Raju. In the print statement, greet Rajesh got executed and it said, therefore, good day, Rajesh. But the function returned value 6, which is the of length of the name. Obviously, since it was Rajesh, the length was 6. And greet 1 actually, because the function got executed, it said, good day, Rocky, but it did not return any value. So, in such case, you will see that when Python doesn't resort to saying that there is no return value to this particular function, okay, it just assigns a value, a special name, a keyword name called as none. So, none is an indication that it is, especially for functions, a none would mean that there is nothing that has been returned by that particular function. So here, that is the main, what you can say, takeaway, that functions that return values, those values can be received, stored to variable, or printed. Here I have printed, I could have stored it to variable also. And functions which are void, which return nothing, they still can also be executed. Try to If you try to return it to a value or print, it will return value, obviously nothing, because it doesn't have a return statement inside it. But the Python treats it as nothing is returned, and it indicates so by a keyword called as none. Okay, keyword called as none. Okay, fine. So this is as far as the functions are concerned. Okay, I will save this and we will close this also. Now, last thing is that a function can be made with, a library can be made with many functions. Okay, so different many functions can be taken and we can make a library out of it. So I will just try to create a library out of this, or what is in Python called as a module. In structured scenario will be a collection of function, and a module in object oriented scenario will be nothing but a collection of a class with its methods. Okay, basically a class will be there, so obviously class will indicate to an object which will be required to be instantiated, and then of course whatever are the methods in the class specified, they can be accessed as the methods of the object instance as well, and that allows all the libraries to be very easily used in Python. Okay, let's see first how I will be able to do it. So what I will do is that we will just open the last one, the very recent one. Okay, and I will take these three and make a module out of this. Although it is, what you can say, a senseless, it doesn't have any meaning as such. We could have had very easily having some mathematical functions collected together into a meaningful library. But since these are available and we are trying to save on time, we will do it. Fine. So I will just put it here. Okay. So now this is my collection of functions. Animals, greet, greet one. Okay. I will try to save it. So save as. I will give a little bit different name. I will say module 1 dot py. Okay, I will say module 1 dot py and I will save it. Okay, and now I will close these programs and I will write a new program with, of course, the name program. Last one was 7. So now we will have 8. Program 8. Fine. Now, what we should be doing is I want to use function animals, function greet, and function greet1 in some other program, like say the program which I have just opened. What to do is very simple. I have to say import and the name of the module. So I am having in module 1. You will see, in fact, Spider is automatically recognizing module 1. Why? Because my module 1 pi is available in the same library which is there, and it is also recognizing it to be a module. Why it is recognizing it to be a module? Because it doesn't have any main execution program. Okay, it is just a collection of def or functions. Similarly, if there is just a collection of classes with methods, a class library will be there, then also it will automatically recognize it to be a module, uh, and therefore here you can see that अभी अभी मैंने जो module 1 create किया, that has been seen there as a module. It is recognizing it as a module. How to include a module library, either structured function library or a class function and methods, that is class methods library, is very simple. We have to use keyword import followed by name of the module. Okay, so module 1. Okay, so now I have got a module 1 imported. Okay, I have got module 1 imported. Okay, now I want to execute function animals. Okay, so say animals. Okay, I will use the default values, and then I have to, दोनों की जरूरत नहीं है. I will just use function greet, and of course it doesn't have a default value, so I have to give some value, so I am giving some value to it. Okay, so you will see that I am putting it, but my editor or my ID is trying to tell me that there is something wrong with this. There is an error because a brown cross, a brown round with a cross is appearing. That means it is trying to indicate to me that these lines appear to be syntactically incorrect. At the same time, there is an exclamation mark on the import module 1 line also. What is apparently meaning is that I am not writing syntactically correct access to functions animal and greet, which cannot be seen as def in this particular program. At the same time, probably the module 1 I am not utilizing. So what to do is very simple, or how to access is very simple. I have to say module 1 dot. Okay, so I have to say module 1 dot. You will see that animals is already appearing, which I have written, and you will see that the exclamation mark and the cross are gone. The cross on module 1 dot animals is gone because now it is the correct syntax for accessing that function. At the same time, a exclamation mark on import module 1 is also gone because now the module is imported but not used. Situation is not no more there. At least one function animals is being called from that module in this program. Okay, and obviously the point I do module 1 here, the error mark here also will go. So whenever we are accessing a function library or a library in Python, we have to import it. Okay. If I am using a class library, that is a class, a library of classes with methods, there will be one additional thing that will be required, and that is nothing but that I am needed to instantiate that particular class. Okay, so how to instantiate, we will come to that as we are going to move here from here to NumPy. And so when I move to NumPy, obviously NumPy is an external module library for number churning, and it is obviously most of the generic libraries are ported out as class libraries. So I will be required to instantiate it because the library which I am currently using, or the module which I am currently using, uh, is not object oriented. It is a structured def or a structured function library. It is just accepting it now the way it is in its sense. Okay. So I will save this and run this. So obviously you will see dog1, dog2, dog3 are animals and good day Rocky. So the functions are getting executed in a proper way. So this is the way we can create modules. Modules are those libraries which is nothing but a collection of either simple way structured Python functions or the class libraries or class functions. It will contain its properties and it will contain its methods. Okay, so when I say that a class will have its properties, so variables which are there in the class, they are its properties, and the functions which are defined inside the class, they are obviously the methods of that particular class. And then that there can be a subclass of that or a child class of that or whatever. So as I said, since it is not really needed in this context, object-oriented programming in Python is the area which is not being covered in this particular lecture series. Okay. So this is as far as the functions and their modules are concerned. If there are multiple modules interlinked, it develops into what is called as a package, a Python package. Okay. And whenever a module is dependent on a particular module, another module, or many modules are being used in a program, such packages and modules are needed to execute a program, then we say that the program is having these dependencies. These are the typical words used in Python. Okay, so we are having functions which are just like C or any other language functions. uh, the libraries of either structured or class oriented or object oriented uh, manner, those libraries are called as modules, and the interlinked modules or multiple modules linked into a cohesive solution or cohesive output is called as a package. A package or a module required in a program is called as a dependency because that program happens to use some function in that particular module, or in turn a module might be using function from some other module and a program is using that module. So either way we say that the program is dependent on that module which in turn is dependent on another module. Okay, so all these are called as dependencies. So now if I say from the context of this particular program, module 1 is the dependency of this my program. Okay, so prog 8 is dependent on module 1. It cannot execute without module 1. And therefore if I ask what are the dependencies of prog 8, we have to say that module 1 as the answer. Okay, so this is as far as the functions, modules, packages, and also the keyword dependencies in Python. This is the way in which it is interpreted. Okay, let's move ahead now and start seeing the actual data science flow and then the different tools or libraries, or whenever we write programs in Python for data science or analytics, what are the tools and libraries which are available will use, and obviously they will become dependencies in my program. Okay, so let's turn back to our presentation. So modules are already done. So let's start with the tool sets and what we have already said without losing much time. We are having NumPy, we are having Pandas, we are having uh, Matplotlib, we are having Scikit-learn, Scikit-learn, and they are essentially being using numeric data handling. NumPy is used. Pandas is used for essentially in-system processing of two-dimensional tabular data. Data science visualizations are very important, and they are being done with Matplotlib. And scikit-learn is essentially implements statistical functions for analytical purpose in data analytics. There are few more which you should have just been knowing, and later on can study them. So for data visualization, we are having many other packages which are available. Matplotlib is of course there, but we are having one very good package which is called as Folium, essentially for geographical representations. There is word cloud, which is for creating a word cloud graphs. There is Orange, which is another visualization library. There is Tableau, which is again a data science data visualization library, which are also available. And then, of course, if you want to integrate some machine learning and all, we will be having libraries like Keras and TensorFlow. Okay, so this is the entire, what you can say, a suite or a chain of libraries. All of them, of course, on Python, available in open source. You can make use of them freely without any problem. But today, or rather next remaining 2.5 lectures approximately, we are going to see the data science and analytics part with these four tools or libraries being studied. Again, as I said, they are pretty exhaustive. So we are going to take an overview look on them. Okay. So let's move on to very quickly. What is the data science flow, and analytics are performed on data? What are the steps involved in it? Okay, so first of all, you must acquire the data or capture the data. The data can be acquired from the existing database in the form of CSV file or a JSON file. It can be also acquired from the database live through some SQL query. It can also be acquired from humans, forms entered by humans. It can also be acquired directly from sensors, especially like say the applications in the area of IIoT and Industry 4.0. The data is getting acquired. Huge data is getting acquired from different sensors live on the run. So a machine or a man or an existing database feeds data, and huge volumes of data is made available from where it will be captured. Okay. So typically various methods are there for getting this data in. So they are all called data acquisition and capture mechanisms. Those mechanisms, usually we will say that they are out of data science, what you can say, uh, set or suit, but it will be required that the knowledge of what is the way in which data is acquired. Okay, as I said, it can be sensors, it can be machines, it can be humans, it can be forms, it can be surveys, it can be databases, it can be another websites through some API calls, REST calls, etc. So there are so many different various methods by which the data can come in. uh, Obviously the data which comes in is not in readily usable format, for which a lot of pre-processing is required on the data. So we are required to do data refining and data cleaning operation, in which incomplete data records might be deleted, or they can be populated with some means if it is possible, and rectified. Data refinements is carried out. Sometimes a lot of data is available, like say you might get if we are talking about some cars, you may get 28, 29 fields or columns, out of which I am going to work on only 3 columns. Then we will be required to remove the remaining columns. So in general, data cleaning and data refining is required to be done as a part of data pre-processing. Once the data pre-processing, or that includes refining, cleaning, etc., is done, then the exploratory analysis is carried out on the data. In the exploratory analysis, what it is called as the uh, some basic directions are obtained, some idea about how the way data is indicating, or how the way the data is getting interpreted is determined, and some visualizations are generated on the basis of that, which provides us some insight or some indication into the data analysis, that how it is going to be finally. It, what you can say, gives us indicative trends. Then the actual data analysis is carried out by modeling the data to a statistical or mathematical model. Generally, engineering data can be built to a mathematical model, but normally a data which comes from varied sources, or the big data which is coming, normally is having a certain degree of underpreparedness or randomness in it, and it doesn't normally gets directly fitted to a mathematical model. So it generally is fitted over a statistical model. And that data model, once the model is fit, the data is subjected to that particular model. The data model analysis is then carried out, which leads to the final results being obtained from this data analytics process, which is then reported, and again final visualizations like some graphs etc are made. So reporting generally would mean generating certain tables which will indicate the results. So resultant or final tables which indicate some predictions or whatever's are carried out. On the basis of that, there could be some verbose text also in it, and there will be some graphs. So final visualizations again will be carried out. So this is generally the data science and analytics flow which is followed. Okay, so let's get started with NumPy right away. NumPy is a number processing package in which we are able to create or import or what you can say, receive one or two or multi-dimensional arrays of numbers for processing. As we know, normally we say matrix or rubrics as the names for two-dimensional and multi-dimensional arrays. We typically happen to call sometimes uh, call them as arrays only, or vectors for a single dimensional ones. So, working with vectors, matrix, rubrics, etc., is helped for its processing by packages like NumPy. Okay, so it provides high performance multidimensional array object based tools for working with these arrays. Okay, So in fact that object should be on the lower line. I will, before sending, I will just correct it. Fine. So let's start off with NumPy. Okay. Now let's talk about creation of an array in NumPy as first and foremost the activity. So let's go and go back to our this thing. Now there won't be any programming as such. So I will reduce this window to minimum. This is the window that will be required the maximum. I will clear the slate for NumPy. Also, I will just store this program and clear it up. Okay, fine. So, how I get NumPy? Simple thing, just like any other library, I have to say import NumPy. I have to press return. No error is given. That means the NumPy library has been imported. If some library is not there installed in your Python, you will be needed to install it, which is very important. Okay, all the external modules and libraries will be required to be imported, which is what we have already seen. But there is every chance that some of the libraries or packages or modules may not be currently available on your Python environment, which will happen highly likely, especially for the first time when you are using a particular package. Some of the packages like NumPy, etc., are very commonly used, and nowadays they come with the Python bundle. Now, for me, it didn't give any error because my machine, I have actually installed the Anaconda suite. The Anaconda suite has installed Python on my system along with approximately 221 packages already installed from different walks of life. So it has NumPy, it has Matplotlib, it has Pandas. For image processing, it has OpenCV2. For machine learning and artificial intelligence, it has Keras, TensorFlow. For visualization, it already has Orange, and so on and so forth. So all these packages are there, but they may not be there. Suppose it is not there, what to do? In such case, you have to go to Python environment. Okay, so I'm here, and here I have to say pip, that is Python package installer, which is there. So pip is Python package installer, pip install numpy. Now it will say already installed for me. But if import numpy in Python gives you error saying that no such package or module, then you have to have this installed. This has to be done at the command prompt. Uh, as I said, if I say import XYZ, you will see that no module named XYZ which has come. Okay, a similar error, module not found error, will come for NumPy also if it is already not installed on your system. In such case, you have to go to the command prompt and you have to install NumPy. Keep in mind when you are performing this operation, your machine should be connected to the internet because it will get that particular module files from the internet. Okay, so obviously for me it didn't install because it says requirement already satisfied NumPy in the packages which are already loaded in my Anaconda suite. Okay, so requirement already satisfied. So I'm already having it, and which was pretty good clear when actually I had done import NumPy, and it was successfully completed. Okay. Now, as I said, NumPy is a class library. It is not a structured function library. So because it is a class library, it is better to have it instantiated. So what is to be done in such case is import NumPy, the whole NumPy as a class library will get imported as an instant created called as NP. Okay. So now I have created. So what import NumPy as NP will do? It will not only import the entire NumPy library, but the whole class, the main class NumPy, will be instantiated as NP. Okay, it will be instantiated as NP. If I want to import only a subclass from library, you can do that also, which is having a slightly different syntax. It says from, okay, because I have already imported the whole of a NumPy. At the moment, I will not do it here. I will use some other library which is actually not really in context for this particular work, but just to show you that syntax, I will very quickly uh, show you that with some other library. So I will say this is actually GUI library from tkinter import ttk as. Okay, so what is the meaning is that, so there are three ways to do module import. Okay, so what you see on line number 52 here, import NumPy, it imports the module. For structured functions, it is good enough. For class libraries, it is still imported, but no instantiation has been carried out. Then your program must have a line which will instantiate it, something like np equal to numpy, open bracket, close bracket, etc. The line 50 is importing NumPy, but importing it and instantiating it. A local instance has been created for the entire NumPy object in the name NP. What is 51 is that tkinter is a GUI library. From there, I am only importing one component, which is ttk, and also I am instantiating it as ttk1. Okay, so I can do it in, so these are the three syntaxes which you can follow. Import module name as instance, from module name, import object as instance. Okay, these are the three different syntaxes you can use. Okay, so now here, of course, I will now just kill this kernel because it has unnecessarily been loaded with many libraries. So I am generating a fresh kernel of Python, and now I am doing say import numpy as np. That is what I want. Okay, so import numpy as np. Now, how I can create an array in NumPy? So there are, what is the method by which I can create an array in NumPy? Let's see. Okay, so I will say that A, suppose, is created an array np dot array. So this is my function, and I can pass a variable here. I can pass directly a list here. So I will just pass a list here. Directly a list of 5 elements is passed. Other way around, a list or a tuple, anything which has been created, another sequence, you can pass it on as array here. Okay. So what is A? It says that A is 1, 2, 3, 4, 5 array. Okay. If I say type, what data type is obviously it will have now a dedicated data type which says numpy.nd array. Okay, numpy means numpy package module, and nd array is the actual object of that particular uh, data type. So, as I said, all derived and sequence data types in Python, they are essentially objects. Okay. So numpy.nd array. So nd array is the object which is there is the data type of that. Now let's see two very basic properties of an array. So what are those two basic properties? One is say a dot d type. So what is the data type? Okay, it says that because it is an array of integers, and integers in numpy are 4 bytes, that is 32 bits. So it says d type int 32. Okay, and a dot shape. Okay, you will see that I am not using open bracket close bracket here. Okay, which is very peculiarly different from earlier points when I use that. The reason, say for lists, list dot clear, open bracket close bracket, everywhere we are using that. Okay, so whenever you are having a def, that is a function or a method, I am using it, but these are the properties of this particular one. So because they are properties, there is no open bracket, close bracket. Whenever there is a method, there will be open bracket, close bracket with or without arguments. Okay, so what it says that it is 5 comma. The meaning is that it is a single dimensional array of 5. Okay, can I create multi-dimensional arrays? The answer to that is yes. I can create multi-dimensional arrays. How to create that is using a double bracket, and I can say 1, 2, 3, bracket complete, comma 4, 5, 6, bracket complete, and function complete. Okay. So now what is the meaning of this is that the inside list 1, 2, 3 is first row, inside list 4, 5, 6 is second row. Okay. And so what is B? 1, 2, 3, 4, 5, 6. Okay. Now if I say what is the shape of B? Sorry, I have not created to array. Uh, just a minute. What we will do is that I will create B again. B is not this. I want to make this into a numpy array. So I must say np dot array. np dot array. Okay. Now it is correct. So what is B? It is array C 1, 2, 3, 4, 5, 6. Now it is depicting it correctly. And A dot, sorry, this is B. So B dot shape. You will see that it is says it is a two-dimensional array with shape 2 comma 3. 2 comma 3 means it contains two rows and three columns. Okay, it contains two rows and three columns. Okay, so in the same way, I can say that 1, 2, 3. Okay, so now what is B? You will see that it is not writing it horizontally, it is writing it vertically. Why? Because first row has got only one element 1, second row has got only one element 2, third row has got only one element 3. That means there are three rows but only one column. And therefore, if I now say B dot shape, it will say 3 comma 1. So there are three columns and one row only in this. Three columns, one row only. Okay. On the other hand, so we can say that if I am having one say C1 np.array 123, comma 456. Okay. I missed one square bracket here. You know what has happened? Because I have a fresh kernel instance, the NumPy is not running. So I need to do that. Okay. So I will say import NumPy as NP, and now I will create it. It will be successful. So module should be loaded when I start using the module, or the instance of an object inside the module should be loaded when I start using that object. Okay, which is very standard. And say I do C2 equal to np dot array, and into bracket I am having 1 2 3 4 5 6 close bracket. Mhm. Okay. C2 is equal to np dot array. Just to be very careful. So now C1 dot shape, C2 dot shape. Okay, one is 2 comma 3, the other one is 3 comma 2. So in this way, we can create arrays in NumPy. Now the question is that can I access a particular element of an array? The answer to that is yes. It is very similar to lists, or essentially list inside a list. So I have to say C1. The only difference is that I don't have to write it in two square brackets. Instead of that, I can write in a more conventional way like this. Okay, so it says 5. So C1 1 comma 1, 1 comma 1 is 5 because first row, first column. Okay, if I say C1, you will see that 1 comma 1 is this element, first row, first column, 0 to n rows, 0 to n columns, 0 to m rows, 0 to n columns. So I can access this. Okay, and can I change it? The answer to that is also yes. And say I put 8 and again see C1, you will see that 1 2 3 it is 4 8 6. So 5 has been replaced with 8. What does this mean? What does this mean is very simple, that the NumPy arrays are mutable. Okay, NumPy arrays are mutable. Okay, so moving ahead, as I said, the NumPy arrays essentially draw most of their properties which are quite analogous or similar to that of the basic Python lists. And therefore, we can have this kind of a notation which is also very similar to lists. The only modification is that in list, I would have required to do C1 open bracket 1 close bracket open bracket 1 close bracket. Rather than that, I have to say 1 comma 1 in a single close bracket, which is a more conventional way to handle, like say in languages like MATLAB and all, you will find the elements of vectors and matrices are arranged or rather accessed and modified in this way. Okay, so this is as far as the basics of NumPy arrays are concerned. Let's move ahead and see their what you can say uh, changeability or configurability, interchangeability with respect to the list. And for that, there are a couple of functions which are called as reshape functions. So suppose I am having a list and I will create a list like say L1 just like yesterday. So I will say the L1 I for I in range 1 comma 11 which will create 1 to 10 list with a with a single uh, comprehension in. Okay, with a single comprehension. Now, what is L1? L1 is nothing but 1 to 10 numbers. And if I say it that it will be a NumPy array which will be required to be changed in shape. So I will have to do, first of all, convert it into array. So I will say A is equal to nothing but NumPy array of, now I will straight away pass the variable L1. So A is array. You will see that NumPy array is seen from numbers 1 to 10. And then I will say A dot reshape. I can say do a reshape 5 comma 2. You will see that the array will change to 5 rows, 2 columns. Okay. You will see that it has been changed to 5 rows, 2 columns. Okay. So that is one way. So L1 is still there. So I will again create it. And this time I will reshape it 2 comma 5 rather than 5 comma 2. I will reshape it 2 comma 5. So obviously it will be 2 rows and 5 columns. So I can write the numbers creating from a vector. I can create 2-dimensional or multi-dimensional arrays. Okay. You will see the difference. Okay. At output 15 and output 18, there is a clear-cut difference. One, the same array taken from a list was reshaped in 5 comma 2, that is 5 row 2 column format, and in second case it was reshaped into a 2 comma 5 format. Okay, now I can, so what is A now? It is this, and A comma reshape, suppose I say B is equal to that A comma reshape. Okay, the A comma reshape is there, which will be taken to another vector B or another 2D in B. So it is obviously a reshaped vector. Now, if I, sorry, it scrolled to history. Okay, so if it is a two-dimensional array which is there. Now, if I say C is equal to B dot ravel, okay, what will be C? C will be again array of 10 elements. So in short, if I want to convert that particular array back to a single dimensional array, I can also do the same reverse operation as a reshape. So any reshaping of a single dimensional array into multi-dimensional array, I can revert back to the original single dimensional array, or I can extract back, uh, I can ravel back the array and get it using a ravel function. So reshape and ravel functions are those which can actually allow me the interchangeability with a single list. I can import NumPy array. I can convert them into multidimensional. I can reconvert or again flatten them into the original single dimensional arrays. Okay. If I want to have the actual data type interchangeability with respect to the list, if we need a data type interchangeability with respect to the list, okay, then we can actually use a toList function. So if I say toList function with respect to C, okay, and if I put it to say L4, it will, sorry, what is wrong? Very simple, because toList is a function of object np inside the module. So I have already instantiated it. So why it is not saying? Okay, okay. Actually, we have to do, yeah, there is a different way to use that syntax. It is C dot toList, because C is already NP array. So C dot toList, okay. Rather than toList into bracket C, it is C dot toList. And I can see now what is L4. It is the original list. So in short, uh, I can convert array to list using toList. I can convert by np.array, a list can be converted into the array. Okay, a two-dimensional list can directly be imported as a two-dimensional array. That means if I take, say, one list, which is say 1 comma 2, which is a two-dimensional list. Okay, so L3 is a two-dimensional list, and if I say A is equal to np dot array into bracket L3, it will generate a two-dimensional array, as you will see rightly in output 31. Okay, so that is something like the Python data type list and its interchangeability and its portability with respect to the NumPy arrays. So they are freely interchangeable or portable and convertible. Moving ahead, now let's see a few of very readily used NumPy arrays. Okay, some very readily used NumPy arrays. Like, say, if I say A, and these functions will be very useful in operations, especially with matrices. Okay, so if I say np dot zeros, okay, np dot zeros, and I put the size to be a tuple 2 comma 3, np dot zeros. np dot zeros is 2 comma 3, then you will see that it will generate the array of 6 zeros. See the difference. It is generating those arrays with the floating point numbers. Okay, we can say D type to be integer. But here, if you say now what is a D type of A, it will say that it is float 64. So generally, because it is a number crunching package, integers are big, 4 byte, and floating point numbers are even bigger, 8 byte storage. That is 64-bit storage that is being provided in there. Okay. So in short, np.zeros creates an array of 6 zeros. Similarly, if I want to generate the matrix of ones, I can do it by np.ones, and in such case, it will create a matrix of ones. Similarly, if I want to generate an identity matrix, I can say np.I. Of course, now I will require it to be whatever dimensions I have to give. So because identity matrix is square, I have to give only one dimension, and it will generate. You will see that it will generate an identity matrix, okay, to be like this. As I said, any one of these commands, I can include an argument d type if I want it to be integer or float explicitly. So if I do integer, then it will generate an array of integers. So you will see that a very handsome looking array will be seen, just like identity matrix that we see with diagonal elements 1. Okay, it can be done in so generally, of course, the matrix functions we will have to write. There are no ready-made matrix functions available here. Okay, the ready-made matrix functions can be available with another module which we are not going to take, called as scipy, scipy. Okay, just like NumPy, there is scipy, where a lot of vector and matrix processing functionality is directly provided. So which is what you can say a much advanced module as compared to NumPy. It is advanced. NumPy itself is big, but scipy is even bigger. So uh, we can generate a matrix of random numbers, if I want to generate a matrix or a vector of random numbers, then we can do so by saying np dot random, np dot random dot random. So random has got a function random. Okay, so random is a object under module np, and random is a method of that object. So np dot random dot random, and of course, if I want to generate a 3 by 3 matrix on that, we can generate. You will see that a randomly generated. Obviously, those values between will be between 0 and 1. Okay, those values will be between 0 and 1. If I want values to be any random values, like say integer, I can say random integers, and those values will be generated. If I want the random values to be generated between two specific values, that also can be done. Like say, if I say I want values between 5 and 20 and having the shape of 3 by 3 or size of 3 by 3, then I can generate that, and in that case you will see that it will generate any two values which are there between the given range 5 to 20, and it will randomly generate to fill it. Okay, obviously here the 16 will be getting uh, I want to create a random vector, then I can generate a random vector of size 10, maybe value having random values between 1 to 100, which is very commonly required many times while testing statistical functionalities. I can do so, and you will see that I have generated a random vector of 10 elements, and the numbers are randomly spread between 1 and 100. Okay, it uses a pseudo random number generation algorithm internally. Okay, so that is as far as the random number generations many times are useful, because whenever we want to we want to see the distributions, we have to throw input values in a random manner and get the output values to plot that. So generally, to view histograms or to view distribution curves, these functions are used very widely or profusely. And because statistics is one of the major bases in analytics, there also, therefore, it is required quite profusely. Okay. In addition to that, NumPy also specify. I think I will overshoot by around 5-6 minutes today, or maybe 7 minutes today, because at least I will finish off NumPy basic things. I hope that is good. Okay, so that at least we can start straight away with the next tool tomorrow. Okay, so I can do slicing very easily. So if I say I have generated a random matrix between 5 to 50 like this, and if I say a into bracket, suppose I say 1:3 comma :2. The meaning is that, what is the meaning of this slicing? Okay, all slicing rules are very similar to lists. So I will just take one single example. So what the meaning of this is that column number one included, three excluded. So it will essentially take column number one and two. The columns are numbered 0, 1, 2. Sorry, rows are numbered 0, 1, 2. And columns colon 2, that means two excluded. So it will take 0 and 1 as columns. So in short, rows 1 and 2, columns 0 and 1, it will show as the output. So you will see that it has taken 5, 5, 12, 23. And suppose I send it to another one. So obviously B will be a sliced matrix 5, 5, 12, 23. Now, if I say B 0, comma 0 is equal to say 67, it will change the value. And if I say B again, you will see that the value is changed to 67. But because it is mutable, you will see that the value is also changed in A. Okay, so you will see that the we had taken rows 1 and 2, columns 0 and 1, and that value 0, 0, which happens to be actually value 1, 0 in the original matrix A. The value 67 is in the changed condition. Okay, then there are certain trigonometric and mathematical functions are directly available in NumPy. So if I say a pi value is directly available, you will see that the point I say np.pi 3.141592, whatever is the pi value, up to whatever precision digits it can calculate, will calculate and show it to us. Then I can have a sine, cos, tan generated in this. So I can say NP sine, angle will be required to be in radians. So if I say sine 2 pi, sine 0 is 0. So maybe if I say 3.14, it will be a very value near to 0, because I have put radians to be pi. And of course, if I take 90 degrees, which is nearly pi by 2, which is exactly half of it. So it is 1.57. It will be value very near to 1. So sine, cos, tan, all these trigonometric values and values can be carried out. So np dot square root can be generated. So it will return a square root. So majority of the mathematical functionality is provided in NumPy. Mathematical functionality is provided in NumPy. Similarly, you can add two arrays, subtract two arrays, multiply two arrays, but it is not a matrix multiplication. uh, Divide two arrays, it is a element to element addition or element to element subtraction which will take place. So that is what I will take as a last, second last, and the last thing I will show a transpose, and then we will conclude on this for the basic tutorial or the overview tutorial of NumPy. Okay, so I'll just show you. Suppose I create A as np dot array 11 comma 22 comma 33 comma 44. Okay, and B is equal to np dot array 1 comma 2 3 comma 4. Okay, so A is this. Okay, so A is this and B is this. Then in such case, I can do A minus A plus B. You will see that the element by element addition will be carried out. If I do A minus B, you will see that the element by element subtraction will be carried out. A multiplied by B, it is an element by element multiplication, not matrix multiplication. We will have to write a small program to make it into a matrix multiplication. So 1 into 11 is 11, 2 into 12, 22 is 44, etc. And A divided by B will obviously here be all 11. So it will generate a element by element matrix multiplication, division, addition, subtraction, which can be carried out. You can also create a square root of element by element. So if I do square root, sorry, a dot square root, np dot square root a, you will see that each one of the number has been square rooted from the A matrix. So that is the way we can go on easily performing mathematical operations. Okay, basic trigonometrical operators, basic value of pi and square root and basic functions can easily be performed in NumPy. And finally, okay, we are having A to be this. Then if I say A dot transpose, you will see that A dot T is a transposed matrix. So 22 and 33 are interchanged. Diagonal elements remain same, and you can create a transpose of two-dimensional array quite easily using NumPy. So all these facilities are there. which you can do. There is also a dot product which is available. So if I say mm, A dot B, it will generate a dot product. Now you can just see what was my original A and what was my original B. From there, we have to see whether a dot product has been generated correctly or not. So we can see that yes, the dot product has been generated in a correct way. Okay, so you can do that. But again, this is not a matrix multiplication. It is essentially what it has done is sigma xi yi. A dot product has been generated. Okay, the each position is a different sigma xi yi in matrix multiplication. So this is not a matrix multiplication. This is still element or row, first row column wise dot product which has been generated for the operations. Okay, so it is the way we can see it uh, in NumPy. So all these operations can be carried out in NumPy. And I will close this session now with one last function which is there. And that last function is related to creating the linear space vector using NumPy, which is very useful in generating the x-axis on most of the visualization. Whenever we are doing data visualization, we need to create the x-axis. For example, I want to show a graph. We will see it tomorrow. I want to show a graph for something in which the x-axis is every alternate year value of something starting from 2010 and going up to 2022. Okay, so I have to one shot. I have to create this particular vector. So how I will create this vector is something like this. So I will have x is equal to np dot a range. I will generate a range, which is the vector. I will say 2010. I will say 2022, and I will say a step of 2, which is there. Okay. So 2022, unfortunately, here could be excluded. So we will have to go and maybe write 2024. And then if I see what x vector has been generated is what I want on x-axis of my graph. Okay, this is very common, very commonly required. So you will see that values are now readily available to me as my x-axis. 2010, 12, 14, 16, 18, 20, 22. Okay, which is vary. Or I want to create a numeric range array starting from 10 and going up to 70 in the intervals of 5. So I will can very easily generate it directly. So mostly linear space generation in graphs and plots for visualization requires some uniformly spaced x-axis variable, which it can do it very easily. Okay, sometimes the function is having its sister function, which I will use. It is called as np dot line space, lin space, lin space, in which we can say start as 1.0. I can say the end to be 6.0, and I want to divide this. It is a total space of 5. Now in a range, we have to give the step size, whereas in linspace, I have to give that this particular interval 1.0 to 6.0 should be broken down into how many different samples. So say 50. Now if I take that, you will see that you will get this. Now one would have expected that it will be whenever I am dividing it in 50. Okay, in just minute, 1 minute or 2 minutes, we will finish off. From 1.0 to 6.0, when I divided into 50 intervals, uh, it should have given me 1, 1.1, 1.2, etc. But it has not given. That is because if I want to do that, I should have actually put it into 51 numbers. Okay. So if it is in 51 numbers, now you will see that it has perfectly been divided 1, 1.1, 1.2, 1.3, like up to 6. So again, I have generated a linear space x-axis for visualizations. So you will see that most of the plots, bar charts, histograms, they require a linearly spaced x-axis which can be generated by step size using arrange function, or it can be generated by number of equated samples by using linspace function. Okay, so these two numpy functions are very, very important in that sense. Okay, so with this, we conclude the numpy overview. I will just take myself back to the presentation for a minute, and this is all, in fact, whatever has been written in here. So reshape, ravel, toolist, etc. Indexing, slicing, mathematical functions, trigonometrical functions, vector operations like addition, subtraction, dot product, etc. that I have shown to you, and functions for random array generation and linear array generation. That is what the arrange and linspace functions that we took in the end. Okay, so that's all for day 3. Thank you very much for being with me. And with this, I think we will conclude today's session. And I will stop sharing my screen. Thank you very much and good night to you all.
Thank you, sir. So, with this,
Yeah.
we'll end today's session. And thank you so much, everyone, for joining us today. And please do join us tomorrow at 5:30 p.m. as we'll be continuing this session further. Thank you so much for joining.
Okay, okay. Thank you very much.